We are now done on walls. We'll move through to floors. This is relatively easy for this project. We really just have a 100mm slab on ground with 50mm slab edge insulation of R1.8. Slab edge is generally modelled in Chenath as the average for all floor areas, so it's easiest typically to put it in for the whole project there as 1.75, closest to 1.8. Our default constructions are all correct here. We'd note that there is this roof space soffit as a floor. If this overhang here, the eave or the entry alcove or this veranda here was connected to the roof space, we would be entering some area in here manually to create that approximation of space and model the heat flows through that soffit that might be through this section here, and then we're able to tell our clients that, oh well, you can insulate this soffit as well and improve your energy model further. If you don't have any soffit, you just leave it zero, it's not modeled. We've got our concrete slab. It doesn't have any underslab insulation. In terms of floor coverings, we'll go through that now. We have concrete, tiles and carpet. So the bathrooms are tiled, the habitable spaces and that hall are carpet. So 1, 2, 3, 4, 5 carpet, bathrooms tiled. These spaces here as well as the study are all exposed. So all of the adjacencies there are correct. We've got a ground adjacency throughout this project. We'll move through to the ceiling tab. So currently the default throughout is of a flat construction. We'll go to the plans, which in this example they've split the ceiling into a construction and then the roof into a construction, and then for the pitch section they've shown the whole assembly. The ceiling is just a 10mm plaster with R2.5 insulation has been suggested. The metal deck roofing with an R1.3 insulation blanket, reflective sarking facing down, is going to be our main assembly here. So it's a metal roof in a roof space, and it's got R2.5 ceiling insulation, R1.5 roof insulation, reflective down. Our pitched roof section is a very similar construction, but with that ceiling on a pitch, R2.5 10mm plaster, and again a reflective airspace. A lot of projects don't have the ceiling type details, so you have to be judging it off the plans here. This is our flat pitch section. Let's get this set up so we know that it's correct. It's a flat frame skillion metal roof and cathedral plasterboard ceiling, so this would be the most appropriate flat roof assembly for us. And we know it has 2.5 ceiling insulation, and its roof insulation is a 1.3 blanket with a 0.05 reflective, that's the emissivity, reflective airspace value. So that's going to be the most appropriate for us. There's non-reflective options there, and there's even blankets installed with reflective finish facing up. So here we're reading it from the external side in. It's going to be this is our blanket. So the rest of the ceilings throughout the project are going to be the roof space adjacent construction. It was an attic type, so we could either change to type attic. We've got our 4 attic types here of a metal, concrete tile, clay, ceramic tile with flat ceilings. This is what we're after here, this metal 01 pitched metal roof with a roof space and a flat plasterboard ceiling. Again, R2.5 ceiling insulation, and we'll find an R1.3 insulation blanket, 90mm reflective airspace as our roof insulation through there. We can now move through this to ceiling pitch. We should put in the pitch here so that our area of ceiling is accurate, 8 degrees pitch. So watching this area, 55.5 becomes 56.1. The adjacency type is correct here. We've got one that's just external, doesn't face a roof space, it's full, and the roof space adjacency for the other attic. Modelled as a minimum ventilated roof space. Our other options there are whether it's naturally ventilated with Eaves vents or whirly birds, those kind of things. In terms of solar absorptances, our roof solar absorptance is 32% here. It's for all ceilings. Oh, there's some here straight away. Classic cream. Sounds wonderful. So that's our ceiling section of the DataGrid done. What we've done when we've created this attic space is we've created a roof space zone. That was already created by us connecting some floating walls to a roof space zone. All of those floating walls are now connected to that shared roof space, and we'll be able to see that roof space in the Zone DataGrid tab. It's here, roof space, and we'll talk about that at the end of the tutorial. It'll need some tweaking. So moving on from the ceiling data grid tab, we can go to our openings and move to our window schedule and get the right heights and specifications in. As you can see here, they've put in the window schedule the two different specifications for each opening type. So we've got a lot of casements with a fixed pane next to them. We've got some sliding door sections here, and we've got a glazed door and our door schedule there. Because they have specified both of them and better flexibility in terms of window specifications, it is generally best to split those windows up. So let's go through and within the visual view, chop those up now. And we'll see here each of those by being numbered correctly when we split them, which you can see here when I split window 2. We'll see here window 2 and window 2-2 are available. Window 3 is another split type. The sliding doors and windows are a single specification, we can leave those. Window 8 will split. Windows 9, 10, 11, 12 are all single type, as is 13 and 16. Window 14 is the last one we'll split. Okay, we'll sort by name again, just so they're all grouped together. And this is where having an additional monitor is always handy, so we don't need to flick back and forth. But window 1 and 9, 720 width, and they're 1800 and 2400. Ceiling height, 1800 high, 2400. So I'm just doing the widths and heights at the moment. Casement, 90% openability. Window 2 here, we might rename that window 2 right and window 2 left, and the same for all our split windows, just so when we're going through we know, one down here we might call M for middle. So window 1 and 9 done. We could go through all of the window 2, 3 and 8. They're all 1500 high windows and get their heights right. So they're 1500 high with a 2100 roof height, 1500, 2100. And we can select our casement sections of those. They are 850 wide for window 2, 3 and 8. Our fixed sections of windows 2, 3 and 8 are 1800, 1800. Okay, the sliding door sections 4, 6, 5 and 7 will do their widths. They're all the same at 3500. The lower sections of 4 and 5 are 2140 high. They're a sliding. I forgot to select type of these windows here as a fixed type. Window 6 and 7 are sliding above. They're 500 high and their head height is at 3300. Again, they're a sliding type. Window 9 and 10 here, 9, 10, 720 wide, 9 we've done its height, 10 is a double hung, that's 1200 high, 2100 height, 11 is a casement, that's 1200, similar to 12, 610 wide, 550 wide. And they're both 1200 high casement types. Window 13 is the glazed door, 820 by 2040, and its head height is also 2040. It's a casement as well. Southern window is 800 high at 1700. And the left and right segments are 850 wide. Middle segment here is 1740. And they are both awnings, so they can stay. Window 15 is 1200 and 850 wide, and it's a casement. And window 16 is our garage door type, similar to the other glazed door. Now we can go through and do their specifications. If you were making this decision yourself, you would be obviously finding them within the window library. You'd be looking for whether they were aluminium or other, and you'd probably be then finding them for the specific style types, awning, sliding, etc. Here the designers specified our window types for us. And for our casements, we're using that has default aluminium A double glazed clear. And for our fixed sections, we're using aluminium B default double glazed clear. And our sliding door is also the same. Again, the double hung will be the same as that sliding door. Casements using 003. And the only change of that spec is a timber glazed door it's using the default Timber A single glaze clear. So we could clear our selected windows here within the window library and just select our defaults that we're after. We're after Alum 00301A, which is this one, as well as 00401, and then we're after a Timber 00101. So these are 3 selected windows. We'll go back to the data grid and selecting by type. We've got all of our casement windows here. We know all of our casements are going to use the default A, so that's aluminium 3. Our 2 awnings down here will use the same. Our sliding doors will be using the B. Our double hung uses the B. Our fixed sections also use the B, and these laundry and garage doors, they're the timber glazed doors. So there's our windows specifications done, geometries done, opening styles done. We could check out openability for natural ventilation. Defaults here of the casements are all 90, that makes sense. Awnings at 90, slidings at 45, double hungs at 45, and the fixed at 0, so they're all good. In terms of weather stripping and insect screens, we'd be checking our technical guide notes for guidance there. They've specified here all windows and doors include weather strips and fly screens, except window 16, which doesn't have window stripping, and the garage doors do not have weather strip and fly screen either. So that's this garage door here. We could say it's not weather stripped. The frame color, they've actually specified it here. It's quite dark. Solar absorptance 73%. That's different to our default here, so let's find something that's close to 73%, so it's kind of like monument color bond. Okay, in terms of internal blinds, as per the technical notes, we're using Holland blind default. We don't have any external blinds within the model, so we can move on to our door specifications. All of our internal doors are at 2040. We did their widths perfectly before, so we don't need to change that. The door specification is going to be fine. That's just a standard timber door. So it's just our external doors that we want to worry about. Here's D1, which in our door schedule is just a standard 2040 by 820, and its specification is just a solid timber door. It's weather stripped and insect screened, so we've got all that good. Door number 2 is a garage door, so let's put in uninsulated metal door. That'll have a big impact of the heat transfer through that. It's 2600 by 2100, and you might say that those are 100% openable. Its frame colors, whether that was specified or here they're actually noted as solar absorbances for just ease of use. We've got 75% and 69%. And so we've done our doors there. We can move on. We don't have any skylights in this dwelling. We'll move to screens. So we can work outwards as we did from the dwelling in terms of our screens. They're all connected to the correct walls, windows. We just need to get their heights and for this adjacent neighbouring fence and dwelling. So let's go to our site plan. We'll do the internal screens first. We had screens representing these walls here, noting that we do need those screens to be 2400 height. In the entry alcove, it's actually pitched roof over that section, so we did do some manual dimensions before. The left screen will be 3140 and the right will be 2935. This nib wall here is 2310 high, and that's the screens from building itself. We'll move to the fences. All of these fences, given that their defaults, should just be modelled as 2000 height, and they'll also include the 250mm of the ground height, though it wouldn't have much of an impact in the modelling to be modelling the screens just on the level height, which is at floor level. But let's put that in regardless for these screens. We could show the screen base to make this a bit clearer. And we could put their base as -250 and their total height as 2000, meaning that the screen top is at 1750 when compared to anything on the reference plane of the level, as in floor level. Likewise, we could actually do that for these internal screens if we wanted to be pedantic. We'll leave those for now. Our adjacent dwellings will do the same. We'll give them a -250 base height. Our west and east adjacent buildings will do as the average of that, so 3030 plus 4410 divided by 2, 3720. and we need to just make sure we've got their positions relatively good. So clicking this screen here, we can see its projection, or its lowest projection, is 1850 off these south walls, and in the site plan we see actually that dimension is more like 1400 or 1370, so we're just going to want to shift that back until we're closer to that kind of mark. And then this southern building here will just be twice that, so if we were targeting 1400, we'll target this one at 2800 on its lowest projection out from adjacent walls. On the north side, this wall here is at 6600 projection out from the walls. Our dimension here is from the eave line, so it actually shows us here 5915 off. Okay, so we'll get this north adjacent dwelling in terms of heights. It's going to be like 2780 plus 250, about 3 meters. Whereas our south facing wall was going to be more like 44010. So these screens are all done in terms of heights. Let's just get their projections right, as they weren't shown on the plans. They're a bit fiddly to draw. This screen here is about 5.9 projection, and we'd be saying an adjacent dwelling would be that dimension away. The western fence is roughly 6 meters away from the building's edge, and a western adjacent building would be 6,024.4 meters away. So at that point, you'd be considering whether this really needs to be modeled. Our eastern fence is about 5.2 meters away, so we'll move that one in, and this one will be then double that, 10.4. And now we can kind of clean up these fence edges. And we've modeled here the adjacent fences and buildings as per if they're not shown on the drawings, and how you perform that to the NatHERS technical notes guidance. Okay, so moving on from screens now, we've got eaves. We've only got the 7 eaves through here. This is our main northern eave. We're just after getting correct heights here now. We could do that many ways. We could model the vertical shading offset here. It's dimensioned nicely at 250, so it's 250 above the pitched roof, which is this one here. So if we put that vertical height in, we'll see that to these other walls it's actually 1070. Eave number 2 is our southern wall here, who's basically in line with our 2400 wall, so vertical offset is 0. Likewise, how these walls shade each other on those is fine there. The alcove height would be the average of these heights here, so 2940 and 3140, going to be 3040 as the total height of the eave. So we've got a 260 vertical offset there, and put in the correct heights here. So this one would be 3140, and this one is 2940. All of the eaves opacities are remaining 100%. Likewise, that's the same for our screens as well. We left all of those in default at 100%. So we can now move through to the last tab of wing walls. We can see here the wing walls that we've done automatically in manual, and we can step through those, selecting these northern walls. So here is this wall here. We're just going to again just be checking heights. So for a wing wall, that's its vertical offset, and so we'll just cycle through here. These wing walls are going to be modeled, again, it's a pitched setup, so we'd be modeling it as the average wall height for that wing wall that's poking out there, and we know that that dimension is 3600 at its apex there with a 250, so we'd be going 3600 plus 125 as the heights there. So we could just put 125 as our vertical offsets for our top of our wing walls. For our 2780 ceiling, our wing wall heights there will actually be the 3725 average height. Take the 2780, so 945 as their vertical offset. We'll step through the next ones. These wing walls here off the south edge, we can set their vertical offsets as 0. Here it's picked up the fence height fine. 0 wall here has got the fence on its right, and this little nib wall on the left's got its correct vertical offset. Here the wing walls are slightly different here. We could average out that height of that wing wall between these two nibs. That wall's 2310 and that's 2934, 2620 off this wall. That wall here is going up. It has the vertical offset fine. South wall of the garage looks fine. This left wing wall here, dimension needs to get picked up. 2310 is its height. So it's -90 on the left, similar to how it is on the right. These fence heights all look fine. Wing walls caused by the fences and the northern walls there. Okay, so we've modelled now the wing walls correctly. Their heights have been modelled as the main object of the data grid entry for those. One of the last items we need to do is check these special zones that are created within Hero, such as a roof space or a subfloor. When we change the ceiling construction to an attic type, Hero has automatically created that roof space zone above it. It's calculating its area based on not only its shape but the adjacencies that are connected to it. So the main change we'd want to be looking at for our roof space here is changing it into an appropriate shape. We've got hip roofs, which are very common in Australia, two gable facing directions, as well as what our roof space here is a single pitch style roof. You can see the volume of that roof space has changed accordingly. You might want to be manually checking those volume calculations if you're inclined. The other element of this roof space zone that we need to be aware of is this soffit area, and so we'd be going through our plans and making sure that that space, you can see here over the alcove there certainly isn't any roof space adjacency, but we might want to check whether over the southern end of the kitchen, this eave here on the back side of the kitchen potentially could be argued that this is into the roof space of the dwelling, and so we might want to add this uninsulated eave soffit into our model because there will be a heat transfer up here into the roof space. From the northern end, the eave carrying through here on this pitched roof section would not be any style of soffit, and here again, this eave here is the flat roof rafters here, so we wouldn't consider there's no soffit here that's connected into this roof space shape. So we just have that southern area that we might want to model as a eave. We might want to just measure that area there so we can manually enter it. 7.2 square meters. So let's put in a 7.2 square meter uninsulated soffit into our roof space here. That's going to provide some additional accuracy to our model of what we might expect in reality. The other element I've realized here is our eave here on NatHERS TechNote conditions should be having that extra 100mm gutter dragged off it there.